Hi, so my name is Denis Fokin and I'm working at JetBrains. I'm going to speak in English because I don't know French good enough. Sorry about that, guys. So I know that probably some of you came here knowing how OpenJDK project is organized. Am I right? Who tried to build OpenJDK from sources? Okay, I see. So this talk is dedicated to the OpenJDK project and possibilities that it opens. Most people consider OpenJDK is another variant of Oracle JDK. Some are interested in examining internal machinery because lack of documentation. Others prefer find some room for additional optimizations there. We at JetBrains consider OpenJDK as a platform for our products. So in the beginning, I want to introduce some terms. Might be you know about them, but just to speak the same language. So the most famous implementation of Java is JDK, Oracle Java Development Kit. It used to have some benefits compared to OpenJDK. For instance, it contained some binary plugs, some proprietary binary code. Another version of the JDK is OpenJDK project. So it's open source of GNU, GPL, with a linking exception set of tools and libraries. I think we can say that nowadays OpenJDK comes from same sources as Oracle JDK, because these binary blocks were eliminated from the Oracle JDK, so mostly they share the same source code. Java runtime environment, also known as JRE, is an environment that allows executing Java programs and that most people understand as Java. And now we have our own fork of OpenJDK, and it's not Java because of JCK and other considerations. I think that this is enough information to start with. Let me propose the next agenda. I'm going to mention issues that led us to make the fork of the project. As soon as we decided on a solution, we faced challenges, how we responded to them, is it worth contributing back to the OpenJDK project, some thoughts about Oracle support, summing up ideas and questions. The famous Greek scholar Archimedes once said many years ago, "Give me a lever and a place to stand, and I will move the earth." On a personal note, I believe that in the world of IT, I can say, give me a computer and a platform to work with, and I will create a product. for JetBrains IDEs, OpenJDK is such a place where you can stand equipped with your lever. OpenJDK has a lot of bugs in their database, and this could happen because of lack of resources or priorities, or because of some other reasons. But not all hope is lost if you have options available. You can bundle your own runtime. Alternatively, you can purchase support from Oracle or other company. We at JetBrains do the both. While most source code is in the OpenJDK repositories, some companies have their own forks of the OpenJDK project. The OpenJDK FAQ says that the licensing model have solved well over the years, minimalizing proprietary forks and fragmentation of the project. That leaves us wondering, why would anyone want their own fork of OpenJDK? And is it possible to avoid OpenJDK fragmentation? Some problems just couldn't be resolved as part of Oracle support, because they create a fix and provide you a Jerry bundle, and you can redistribute it. Because this absolutely acceptable and understandable for server-side solutions, but we develop client desktop applications. So we needed an environment that we could offer to user, or at least can suggest where the user can obtain it. That's why we decided to redistribute fork as part of our products. Go West, young man, and now when I say young man and West, I mean other repositories. A huge amount of fixes have been put into the JDK 9 repositories. And it seems reasonable to backport them, which is why we're interested in backporting fixes into JDK 8. But I know that some guys already doing it for projects using JDK 6. They even participate in OpenJDK community, maybe even more actively than we. So common ways of solving different issues in runtime include JNI, API, JNA, reflection, and custom DLLs. Usually these are extremely dangerous. Historically, we had a number of such workarounds, but we managed to eliminate most of them. Let me share a couple of examples. Mac OS X file dialogs, also known as sheets, we decided to implement them, and the initial approach was to invoke native Cocoa API through Foundation and JNA. But this approach led to multiple crashes and hangs in the Mac OS X guts. So we have we have written our own implementation based on AWT dialog. So this implementation is not native at all. This is an example when we shouldn't modify Java runtime to achieve our goals. Things became even more complicated when we decided to implement macOS file dialogs because we couldn't simply write our own implementation, as it is much more complex and a lot needs to be obtained from the operation system. So cloud, folders, and so on. This is why we have enhanced the AWT file dialog, and this way we improved these situations. This is example when we needed to modify AWT code in JDK. So why didn't the approach with JNA and Foundation work? The answer is located just in the code documentation. The general rule of thumb for most GUI APIs, Windows or Mac OS X APIs, is that all invocations must be done from the same thread. But Java GUI libraries like Swing, JavaFX, and AWT, in them you don't have access to the thread. And this is understandable because the libraries are complicated. The frameworks are complicated, and even a simple application has an application with a single text field has a lot under the hood, such as accessibility and input methods. On the other hand, the best way to add functionality to library is to incorporate it into the library infrastructure. Multi-platforming takes a great deal of time and efforts, and OpenJDK is supposed to be multi-platform. But sometimes we do not need the pure multi-platform implementation. OpenJDK does, though. Here's an issue, for example. After switching from Apple JDK to Oracle JDK, which meant switching from OpenGL pipeline to direct glyph rendering, the idea stopped supporting subpixel rendering. So I proposed a fix to the Oracle. It was a proof of concept implementation. It was clear that the fix was at the very start of its development, and when we purchased Oracle support, the fix improved considerably. But even then, however, Oracle employees declined to add the functionality into the OpenJDK because the fix wasn't multi-platform. But the fix satisfied us completely. So we enabled the fix in our runtime for Swing components. So now you can see in our products subpixel rendering, and if you run it on OpenJDK, Oracle JDK, you just don't get subpixel rendering. Just because you have the ability to make forks doesn't mean that you can forget about the OpenJDK project. It was the time putting back your fixes. surely as programmer we all must uphold the universal values, and we shouldn't forget about OpenJDK because it's the center of everything. But what is more, other developers can get benefits from your fixes. But first and foremost, let's think why we are making our fixes, why we improve something. Let's say that the goal is the customer satisfaction. This means there are at least two reasons why we should put our fixes back to the OpenJDK repository. The first reason is portability. Some don't want to think about runtime environment, while others prefer use the default. By having fixes in the OpenJDK, you avoid bothering people with environment setup routine. Plus, as an additional benefit, you can decrease the size of your bundle. The second is fallback. You'll be on the safe side in the event of some serious misbehavior scenarios involving your runtime. If you discover such a serious issue, you can switch your users to the OpenJDK binaries. But there are areas where we have significant where we have spent significant time without results, and it seems rather reasonable to purchase Oracle support in such cases. And that is exactly what we did. We want to deliver a robust product, as robust as we can, but the quality of our runtime should be checked, and integrity of our builds should be checked. So here are some techniques that you can use for that. There are some issues. Let's begin with build systems. There are some issues with builds. We know that only one person tried to build the OpenJDK. But if you want to give it a try, there are some issues. It seems that currently Linux is the best platform to build on. But even where you should build free type libraries, things gets even worse on Windows system, where you should use Visual Studio, but you cannot use your make command because it should be adopted to the Sigwin tools. So we built our own modified version of make for that, and after that we use Visual Studio and make, which is we made with GCC, to build our products on Windows. On Mac, after build, all libraries are linked with static with absolute file path, and you should use for building JDK 8 Xcode 4. Now, when we mentioned Xcode 4, we should make a small digression and say thank you to our community, because Xcode 4, you know, it's rather outdated version of Xcode IDE, and it was rather difficult to use it on contemporary versions of operation systems. And a GitHub user made an exciting contribution in our runtime project, and his fix allows our runtime to be built with Xcode 7. So I want to say thank you, Stanislav. I hope the video record should deliver my thanks to you. All the problems I have mentioned before are complicated but solvable. Oracle uses GPRT system to build and test their JDK. But we decided to use something more familiar and general. JetBrains develops its own continuous integration tool, TeamCity. So we use it to build, to test, and to check integrity of our builds. One of the requirements for being called Java is GCK suite. You should pass it to be called Java. This is not our goal. Our goal is to make a platform for our product. But we want to be compatible with OpenJDK runtime and Oracle runtime. That's why we run tests, GTREC tests, GCK tests, harmony tests, and additional performance tests. After running the test, we compare results that we get from Oracle JDK and our JDK. Sometimes they differ. To ensure that we meet our objectives successfully, we conduct numerous of tests for our IDE, we use tests that is written for our products. These tests are completed automatically, and this allows to find us bugs on a more general level. But some scenarios are difficult to implement, so we go through them manually. I should say that we are a happy company because we are developing products for ourselves. So we can test our products internally, and sometimes once you bundle your runtime libraries to internal version of IDE, you can receive feedback in 15 minutes or even less from the office right next to yours. Another way to get feedback is to deliver an early access version of the project. They import our runtime bundle into the early access products and update in the early access products our runtime more often when in release versions. So legend has it that once upon a time in a galaxy far, far away called St. Petersburg, the wise Jedi Master, husband of our colleague, reported a bug in the early access product. It was then resolved within 15 minutes after it was reported, thanks to the efforts of those in our community, and we able to exterminate the evil Sith bugs during the early stage of our product and maintain balance in the force. So since we do not have many fixes a day in our runtime, because a lot of them are really complicated, we can afford builds for every Git push, and this allows us to check integrity of our builds. We select a build with automatic tests, without automatic tests failures, and when we bundle it with our internal DA afterwards with EAP product, and after that the test cycle is completed. But even the approach that I mentioned in the previous slide sometimes can fail. Daily we need to do multiple multi-platform fixes, and even for Linux operation systems, you know, there are a lot of different window managers. For example, on X Windows systems there are Unity, GNOME, KDE. Consequently, we have developed a plugin that allow us to deliver some workarounds and fixes directly to some users and solve particular issues for customers. We have feedback from our customers requesting to make fixes, but do not break compatibility with OpenJDK and Oracle JDK. But the runtime just don't have support for such fixes, for such functionality, and fixes technically could break the compatibility. So since they want to remain compatible with OpenJDK, we try to be as careful and minimalistic as possible, and for that we use different well-known techniques like swing client properties and command line arguments that could be used inside the JRE and do not break compatibility with other implementations. But sometimes it's okay to break compatibility if we mean behavior compatibility. If we break behavior compatibility but preserve API. And national keyboards is such a case. In early days of AWT library, nobody cared about national keyboard supports. So this is why on French keyboard you press command plus equals and get command plus slash instead as a shortcut. And this still happens on Mac with OpenJDK implementation. And in other implementation, we solved the problem, but there are still some situations that are not resolved. I think that you guys are aware of the problem, and it's interesting for me to get your feedback and thoughts on this in this area. In other words, you have the US keyboard layout to work width, and you guys even don't see the characters on your keyboard what you use. We tried multiple workarounds, and all of them failed because of multi-platforming, because on Linux you just cannot get enough information from the system, and because some layouts are more tricky than other layouts, and we have not only French but Dvorak layout and so on. So eventually we re-implemented event handling for Mac. This change is built into the Java runtime environment, not Java runtime, but our runtime environment. And it doesn't fail tests, so we don't break API compatibility. Our runtime sends exactly the characters that you see on the French keyboards. But after delivering the fix, we found out that some people got used to typing let's say mixed layout. So we type blindly. So they just got used to the version of layout where inside you have French characters, and outside you have US characters. For them we introduced a special flag to be back-to-back compatible with Oracle and OpenJDK implementation. So that's absolutely understandable that people just got used and don't want to change their mind so quickly. Do you remember that Fight Club movie? Although the first rule of the Fight Club is do not talk about Fight Club, we'll try to be brave and have a quick chat about that. Two guys meet and found a Fight Club. The protagonist then discovers the awful truth that his friend may not be who he says he is. And in the end, we discover that both of them are actually the same guy. A similar story happened with our runtime. As soon as we switched to JDK 8, we started getting requests from Mac users. They requesting do not swap discrete and integrated video cards from the start. The thing is that some MacBook Pro machines had two video cards. One is powerful and energy consuming. Another consume less energy and is not so powerful. So every OpenGL application tries to get the most from the operation system. So it tries to enable the discrete video card, which is more powerful. Since JDK 8 compared to JDK 6 utilized OpenGL for rendering pipeline, our idea, as any other Java application, asked operation system to switch to the discrete video card. So we developed a fix that doesn't ask operation system to enable the discrete video card. And after that, we started getting other complaints. So because people use IDEs and IDEA for developing program, and they use Oracle JDK and OpenJDK to develop and run their programs in the debugger. So our runtime asked the operation system not to enable discrete video card. And after that, the user starts his program, which is run with, let's say, Oracle JDK. Oracle JDK is OpenJDK application, which is asks the operation system enable discrete video card, and things went crazy. Then users started hundreds of tests. Every time a test starts, it activates discrete video card, and as far as it's finished, integrate video card is activated. So our runtime and the OpenJDK runtime have very few distinctions in terms of overall repository. So just the same thing fights with itself through the native resource. And that is another good reason to put your fixes back into the OpenJDK repositories. So summing up, if you have problems that couldn't be resolved as part of Oracle support, if you know how to fix a problem, but you can't wait the upcoming release, if you want to decide which fixes should go in your runtime, if you need some custom integration between your runtime and platform and environment, you can afford it with OpenJDK. And do not hesitate to contribute your fixes back to the OpenJDK repository. So that's it. And I'm ready to answer your question if you have any.